Okay, Assalamualaikum. So we continue with our lesson on chapter 2 with the example of 2.6. Okay, the one line diagram of three-phase TMB system is shown in figure 2.6. This figure. So select a common base of 100 MVA and 130 kV on the source side. Okay, so this is a figure. The question is, draw an impedance diagram with all impedances including the load impedance are marked in per units. Okay, question A. And then question B. If the motor operates at full loads 0.8 power factor lagging at the terminal voltage 0.4235 kV, determine the voltage at the source bus bar. Okay, this bus bar. What is the voltage over here? And then the motor internal EMF. So motor internal EMF inside this motor lah. Okay, so what is the first step? So we have this question, we have source with this data, and then we have a transformer T1, overhead transmission line with this data 5 kilometers, and then T2 cables, T3, and then we have a motor and a load connected in the parallel at the end of the system. Okay, so what is the first step? The first step, we have to find the base voltage. Okay, to find the base voltage, usually we have to draw the regions. Okay, so if you look at this figure, we can determine this region 1, and then we have region 2, region 3, region 4. We have 4 regions. Okay, 4 regions with different voltage level. So over here we have 132 kV, and then we have a step down transformer 33 kV. This region 3, 11 kV, and then this is another region, region 4, 0.4235 kV. Okay, this is a region. So what we have to do, first step, we have to find the base voltage for every region. Okay, we have to find the base voltage for every region. To find the base voltage, we have to know what is the V base 1. So as mentioned in the question, we have to select a common base of 100 MVA and 130 kV on the source side. We have to select this data as our base case, base parameters. Okay, V base and S base over here. So by using this 130 kV as our new base voltage, we have to calculate V base 2, V base 3, and V base 4. So V base 1 is given. We have V base 1 at the source side is 130 kV. Then we have to calculate the voltage at the region 2 by using this transformer turn ratio. So to calculate V base 2 is equal to V base 1 times 33 over 132. So 33 over 132, we will get 32.5 kV. V base 2. Okay, V base at region 2. So now we have to calculate V base at region 3. V base at region 3, we use the same methods. Okay, V base 3 equal to V base 2 times 11 kV over 33 kV. 11 kV over 33 kV, and then we will get 10.8333 kV. Okay, and same goes to voltage base at region 4. Voltage base at region 4 equal to 0.43. This is transformer rating. Transformer ratio 0.43 over 11 kV. 0.43 over 11 kV times V base 3, then we will get V base 4, which is equal to 0.4235 kV. Okay, now we finish to calculate this base voltage. So the next step is to find the per unit value for all the components. So starting with the T1. Okay, so in this case we have T1 xt1 equal to, this is the old per unit value for T1, transformer 1, times V this is S base new over S base old. S base new as given in the question. This is S base new. Okay, S base new, S base old as stated in the transformer nameplate 25 MVA. This is S base old. V base new as has been calculated. V base 1 or V base 2. We can use V base 1 or V base 2 referring to primary or secondary side of the transformer. In this case, we use 33. V base old 33 is the referring to the secondary side. So V base 2 will be used in this case. So 33 over V base 2. V base 2 is equal to 32.5. So 33 over 32.5. So we will get J 0.4949 per unit. Okay, this is we refer to the low voltage side of the T1. We can also use high voltage side of the transformer to calculate the ST1 per unit new. Okay, if we use high voltage side, so we use this ST1 old times S base new over S base old, okay, times V voltage V old, which is referring to the primary side, which is 132 kV, over V base 1, okay, 130 kV. We are referring at the high voltage side, which is primary side of the transformer. Okay, this is primary side, high voltage side of the transformer. Okay, so we will get the same answer, J 0.4949. This one also J 0.4949. So no matter which side you use, you will get the same answer. Either you referring to the primary or the secondary side of the transformer. Okay, that is for the ST1. So next we calculate the overhead line. So this one ST1. Now we are moving to overhead lines. This is overhead line. Overhead line data is given in the real value, which is 0.2 ohms plus J 0.35 ohms, okay, per kilometer. So we have to times 5 kilometers. So we times 5 kilometers. Then we get this is the total impedance for the overhead line. So we get 1 plus J 1.75. So before we can convert this real value into the per unit value, we have to calculate the Z base for the transmission line. Okay, Z base 2, because this transmission line is fall under the area of under the region 2. So Z base 2 is given by this equation. Z base 2 equal to V line to line base 2 square over S base. Okay, V base 2 as what we have calculated before in the region 2. V base 2 is equal to 32.5 kV square over S base. S base is given in the question, which is 100 MVA. So we will get Z base 2 is equal to 10.5625 ohms. Okay, then to convert this overhead lines impedance into the per unit value, we just divide the actual value with the base value. So 1 plus J 1.75 divide by 10.5625, we will get this value for the overhead transmission line in the per units. Okay, so now we finished to calculate Z overhead line per unit. Okay, next is the transformer T2, same as the transformer T1. ST2 per unit new is equal to ST2 per unit old, this is per unit old, times this one S base new over S base old. S base new 100 MVA is given in the question, which is S base old 15 MVA actually stated on the transformer nameplate. Okay, if we look at this ST2 15 MVA, so we just put it here, times V base old over V base new. V base old as a transformer rating. you look at here, we are taking the low voltage side, which is 11 kV. 11 kV fall under the region 3. Okay, so we have to take V base 3. So we just take 11 kV over V base 3, which is 10.8333 kV. So we will get J 0.6873 per unit. So this is if we are referring at the low voltage side. If we are referring to the high voltage side for ST2, if we look at this high voltage, ST2 is 33 kV. 33 is fall under the region 2, so we have to divide by V base 2. Okay, so if we use high voltage side, this S per unit, ST2 per unit old times S base new as given in the question. This 15 MVA transformer rating, S base old. 33 transformer high voltage side, this is 32.5 is the new voltage or V base new, V base 2 new. Okay, low high voltage side of the transformer T2. So we will get the same answer. Okay, either we referring to the low voltage or high voltage side. Okay, that's for transformer T2. Then cable. After transformer T2, we have cables. 10 kilometers for this cable. So we have R 0.12 ohms per kilometer, X equal to J 0.077 ohms per kilometer. So we have to time 10 because the length of the line is 10 kilometer. Okay, so we will get this value. So the total impedance for the cable is equal to 1.2 plus J 0.77 ohms. Okay, so now we have to find the Z base 3. Z base 3, the base impedance at the region 3 is equal to V base at region 3 square over S base. Okay, V base 3 is equal to 10.8333 kV square over S base, which is S base is equal to 100 MVA. Then we will get 1.1736 ohms. Okay, for the Z base. So to convert the actual value, this actual value into the per unit value, we have to divide this actual value by the Z base. So the equation is like this: Z cable per unit equal to Z actual over Z base. Actual, this is actual value. Okay, this is the base value. So we divide actual by base with the base value, we will get the per unit value for the cables. Okay, this is for cables. So what next? The next element is the transformer T3. So if we look at this figure, we will see ST3. So this is a ST3, same as ST1 and ST2. We can calculate the new per unit value for ST3 equal to ST3 old per unit value times S base new, which is 100. This one S base old, which is the ST3 transformer ratings, 0.75. So in this example, this is a little bit mistake. Okay, there is a mistake over here. This is 755 kilo kVA. It's not MVA. This one is kVA. So this is kVA. So in this case, this is kVA 0.75 MVA because this is kVA. So times this is the old voltage value over V base 4. Okay, this old voltage value at the region 4. This one 0.43, because this 0.43 is at the secondary of T3, which is fall under region 4. So we have to divide 0.43 by V base 4. So 0.43 over 0.4235 square, then we will get this answer. Okay, and we also can calculate the ST3 per unit new by using or by referring to the high voltage side of the transformer. Okay, you will get the same answer as well. Okay, so the next element is load. So this load, if you look at these figures, we have motor and loads. Okay, so how to find the loads elements, impedance of the loads. This is load, this is S, this is voltage, and this is power factor. From this value we can convert into the resistance and impedance value. Okay, for the load, this is the load data. We have S 0.6 mega volts ampere MVA, V line 0.4235 kV, power factor lagging 0.7. Then from the power factor we can calculate the angle of the load, which is 45.5723 degree. So this is three phase. S three phase equal to 0.6 angle 45.5730 degrees MVA. So from this value we can find the impedance of the loads. Okay, so impedance of the loads, or actual impedance of the load, equal to V loads actual square over S load actual, and then they have a conjugate over here. Don't forget to put the conjugate, because the basic equation we have S equal to V I conjugate. Okay, so S equal to V I conjugate. So don't forget to put the conjugate over here. So by replacing VL with the actual value of VL, which is, look at this load. This is the voltage at the load 0.4235 square over S load. S load is 600 kVA. So 0.4235 kV square over 0.6 mega. This one mega VA. Okay, minus 45.5730, and then we will get this answer, which is, this is a resistance value, and then plus JXL. This is X inductive reactance value for the loads. Okay, but this is the actual value in the ohms, units. So we have to convert this actual value into the per unit value. So we have to calculate the Z base first for the load region, or region number 4. So Z base at region 4 equal to V base 4 square over S base, which is V base 4 is equal to 0.4235 kilovolt square over S base. S base is always 100 in this case, 100 MVA, equal to 0.0018 ohm. Okay, so this V base 4 is taken from this V base 4. Okay, because the load is fall under the region 4, so we have to calculate Z base at this region, Z base 4. So Z base 4 equal to this 0.0018 ohms. To calculate ZL per unit, we just take the actual value and then we divide this actual value with the base value, Z base. Okay, so this is Z base, we just divide this actual value with the Z base, then we will get the per unit value for the load. Okay, This is how we calculate the inductance and resistance value for the loads. Okay. So the next element is a motor. Okay. If you look at this figure, final element we have a motor. Motor same as the generator. So we can calculate the motor Sm per unit new is equal to Sm per unit old times S base new over S base old. S base new given in the question. S base old is given at the motor power rating. This is motor rating 0.6. This is motor rating times V base old. V base old for the motor. Okay, 0.4323. This is V base new. This is voltage based at region 4. In this case, because the motor voltage is not given, so this, but we know that this motor is connected at the same bus bar as load. This load bus is have the voltage level of 0.4235, and then this motor also have the same voltage level, 0.4235 kV. So we just take 0.4235 kV, then we will get the per unit value for motor. Okay, Z new per unit for motor is equal to J0 and J10 per units. Okay, now we finish calculating all the per unit values for this example. Then finally we have to draw the impedance diagram with these elements: transformer, overhead lines, transformer 2, cable, transformer 3, and then we have a load parallel with the motor. Okay, this is the circuit for the figure 2.6. Okay. Question B, find the voltage at the source bus bar and the motor internal EMF if the motor operates at full load 0.8 power factor lagging and the terminal voltage is equal to 0.4235 kV. Okay, so based on this data, we can start our calculation for voltage at the source bus bar. Okay, so for question B, we start with the given voltage level at the load bus. So it said that if the motor operates at 0.8 power factor and at this bus bar, bus voltage 0.4235 bus voltage, and then we start with the calculating the per unit value for V base at bus bar 4. Okay, we start calculate the voltage, the per unit value for V4. Okay, V4 per unit is equal to V4 actual over V base. Okay, actual value, it said that the motor operate at 0.4235, and this actual value. Okay, this actual value, the base value is the V base at region 4. So this is V base at region 4. This is the voltage actual over V base actual 4235 kV. The base voltage also 4235. So we will get VL per unit, or V at load bus per unit is equal to 1 per unit. Okay, that's why we get 1 per unit. Okay, so next we have to calculate the motor apparent power in the per unit value. It's given motor apparent power is 0.6 mega. This one 0.6 mega VA. We have to convert this 0.6 mega into the per unit value. So we just divide this actual value over S base new. Okay, we will get the per unit value for S for motor, apparent power for the motor. So Sm per unit equal to 0.006 angle 36.8699 degree per unit. So by using this apparent power, we can calculate the current absorbed by the motor. So Im, or current absorbed by the motor, or current consumed by the motor, is equal to Sm conjugate over VL M conjugate. This V4 is equal to Vm lah, because V4, V at bus bar 4 is actually the same as Vm lah, because this motor connected to this bus bar, this load also connected to the bus bar, this bus bar, VL or V4. In this case, we call it as a V4. So, we got this Im value, Im per unit equal to Sm per unit over V4 per unit. Okay, Sm per unit we have calculated just now, this one. V4 per unit also has been calculated. Okay, so we just divide this value with the V4 per unit value, and then we will get current consumed by the motor is equal to this value. Okay, so what is next? Next, we have to calculate current drawn by the load. So, okay, current drawn by the load. So IL equal to V4 over ZL. So we want to calculate voltage over here. Okay, to calculate voltage over here is equal to voltage at this bus bar. This one already calculated, which is equal to 1 per unit. We already calculate V4 per unit. V over here is 1 per unit. So to calculate voltage over here, equal to voltage drop along this component plus V4. Voltage over here. Voltage over here plus voltage drop along this component. Okay. Or we have to calculate current flowing in this Im, current flowing in this IL. Then we have to calculate total current here. Total current here is equal to IL plus Im. Okay, so this I total. I total times Z total plus V4 is equal to V over here. Okay. This figure, let's say this is our figure. We have this figure. This is source. This is total impedance, and this split into two branches, which is load and then motor. Okay. So first we have to calculate Z total. Okay, and then we have to calculate Im, current absorbed by the motor. This is motor. Sm, this is Z load. So we have to calculate I load to get I total. What we want to find is this V1, voltage at source bus bar, V1. So V1 equal to voltage drop across this component, which is I load, I total. So I total, let's say we call it as I total, times Z total plus V at this bus bar. This is given V4. We have to calculate V4. Okay, and this is equation to calculate V1 or V at source bus bar. Okay. Question B. Okay. Let's say we have this Xm, the current flowing in Im, and then we know the voltage at bus bar 4 is V4. Okay, it's motor, and this EM, motor internal EMF, voltage inside the motor internal EMF, this EM. Okay, if you look at this, let's say this is plus minus, this current flowing in this direction. Okay, so minus V4 plus IM, this one plus minus IM Sm plus EM equal to 0. This is KCL, Kirchhoff current law. So if we rearrange this equation, we will get motor internal EMF EM is equal to V4 minus IM XM. And this equation, from equation 1. Okay, this is how we calculate V1 and also EM. Okay, so what we have to do, we have to calculate what is the value of IM, this one IM, what is the value of I load, and then what is the value of I total. In this case, I total equal to this one I total equal to I motor plus IM. Okay, Z total equal to XT1 plus ZOS plus XT2 plus Z cable plus XT3. Okay, this I total, this Z total. So we calculate I total over here, and then we calculate Z total. When we have all these parameters, we can calculate V1. Same goes to EM. To calculate EM, we have to calculate V4, and then we use IM times XM. So what is V4? So this V4 per unit equal to V4 actual over V4 base. Okay, this V4 actual is given in question. V4 base is what we have calculated at the first step in our calculation just now. We use this value to find the V4 per unit. Okay, so now we calculate what is the value for V1. So now we calculate the IL. IL equal to V4 over ZL. So V4 is 1 per unit. ZL we already calculate previously. So VL and ZL equal to this value. Then we get the value of IL. This value. Okay. So total current equal to I motor plus IL. We just add these two values, and then we will get I total. So next is the equivalent series reactance. The total reactance. This total reactance over here. The idea is we want to calculate the voltage drop along these parameters. So first we have to combine this impedance. Okay, combine this impedance to become Z total. So Z total equal to ST1 plus Z overhead line plus ST2 plus Z cable plus ST3. That is Z total. So we just combine all these impedances to get the Z total. Okay, ST1 as Z overhead line, ST2 Z cable, and ST3. Add all together, we will get Z total. Okay. Okay, so calculate voltage at source bus bar. We just use this equation V1 equal to I total Z total plus V4. So just put the values in these equations, then you will get these per units value. So the final answer must be in the actual value. Because of that, we have to convert this per unit value into the actual value by using the actual or V base 1. Why V base 1? Because the source bus bar is placed under the region 1. So we have to times 130 kV to get the actual value for V1. Voltage at source bus bar 1. Okay? So we get this value. For motor internal EMF, as I mentioned earlier, we use this equation EM equal to V4 minus IM/SM. V4 is 1 per unit minus IM. We already calculate IM, SM. Also we have calculate, so just put the value inside this equation. So we get this value for AM, and then finally we have to convert this unit value into the actual value. We just times 0.4235 kV, which is this is be based at region 4, where the motor is there. So the motor is placed under the region 4. We just times 0.4235 kV V base 4 to get the actual value for EMF. So that's all for this example, question B1 and B2. Okay, that's all. Thank you.